Hi, Dr. Revis here with a short lecture on significant figures. Rules for counting sig figs. There are only two rules that I use. One is called the decimal and one is called the no decimal rule. Warning, do not mix these rules with others. The decimal rule. If the number has a decimal, ignore strike all zeros to the left, the front leading zeros. All remaining digits are counted as significant figures. In other words, if there is a decimal in the number, you only look to the left leading zeros, ignore, strike those, and then count all remaining digits, including any zeros. Be aware that when we say strike, we are simply ignoring them. They are still there, but we ignore them for counting purposes. Rule number 2, no decimal. If the number does not have a decimal, ignore, strike all zeros from the right, back lagging zeros. In other words, if there is no decimal in the number, you only look to the right side, ignore those zeros, and count all other digits as significant. Here's some examples. We have the number 500. This has one sig fig because we have no decimal. This is a no decimal rule. Therefore, we ignore the zeros on the right side. In the next example, we have, let's get a pointer going here. Let's see. So in the next example, we have a decimal point, and therefore we would ignore zeros on the left side. There are none. Therefore, there are 4 sig figs. In the next one, no decimal. Therefore, we simply count 1, 2, 3, 4 because there are no lagging zeros on the right side. In the fourth example, there are 2 sig figs because we have 2 zeros on the right side and there is no decimal. In the case of number 5, there is no decimal. Therefore, we strike or ignore the right side. There are no right side zeros. Therefore, we count everything. In number 6, we have a decimal point. Therefore, we only look to the left side. We ignore these 3 zeros on the left and we count 1, 2, 3 sig figs. In number 7, the decimal point. Therefore, we look for the leading zeros. We ignore this 0 and we count 1, 2, 3. Number 4, we ignore this 0 because there's a decimal point and we count 1, 2, 3, 4. Do not strike zeros on both sides. You will never strike zeros on both sides in any counting process. In number 9, we have a lot of zeros here, but they're insignificant because there's a decimal, and since there's a decimal, we will strike the leading zeros. Number 10, likewise here, we strike only this 0. We have 1, 2, 3, 4, 5. It's important to note when we do scientific notation, when we write scientific notation, we always write all the sig figs. In this case, there were 2 sig figs, 1.0 for number 11, and number 12, there's 1.53, therefore there's 3 sig figs. We do not look at the exponents for considering sig fig counting. Never look at the exponents. In the next example, we have 7.0. There's a decimal in here. Therefore, we would strike the leading zeros, the ones on the left side. And since there are none on the left, we count 1, 2, 3, 4. In number 14, we have a decimal point. Therefore, we strike the front side. And since there's nothing to strike, we have 1, 2, 3, 4, 5, 6, 7. And in number 15, we have a decimal point. Therefore, we strike the front. And we would get 5 sig figs. We show you that summarized here. And so you can freeze this or screenshot this particular slide. Will help you to be able to see examples of how to do this. So we'll only use 2 rules, the decimal rule or the no decimal rule. Now, one way to simplify this for thinking purposes or a decision tree process would be to think about the left-sided zeros and the right-sided zeros, or the left-handed or the right-handed zeros. So here we are. We would ask the question, this is a decision tree process. Is there a decimal? If the answer is yes, that's a left-sided strike. So we strike left side. Remember, they're still there, but we ignore them. Okay, ignore or strike the leading zeros and count. In the example here, we ignore the ones on the left and we get 3 sig figs, or 7.03 times 10 to the minus 2, because I must include all 3 sig figs in my scientific notation. The to the minus 2 simply tells me the place value. I do not use place value for determining sig figs. Let's ask the question again. Is there a decimal? No. Therefore, a right-handed decision, meaning we strike the right side zeros. These zeros are the ones we strike on the right side. So we count all remaining digits. So ignore the lagging zeros and count. So in this particular case, we're going to ignore these two on the right side because there's no decimal. And so we don't worry about what's called an embedded zero. We don't care whether it's embedded or not. We simply count after we struck up to the point where we see a counting digit. So we have 1, 2, 3, 4 sig figs. And we will write the scientific notation will be 8.101 times 10 to the 5. In this particular case, because these are all significant figures, they must show up in your scientific notation. And by the way, when writing scientific notation, you only have one digit to the left of the decimal. Always one digit to the left and the rest of the sig figs. It's important to note when it comes to the place value. The place value or magnitude of the number does not change. If your number is in the thousands, your answer is still thousands, except in terms of writing, we only show or report one of the sig figs with the rest of the digits to fill out the place value. Add in zeros. If we want to retain place value, we can use the math process of including zeros. Adding a decimal. Occasionally, we'll have zeros at the end of a number that's significant, and we'll need to add a decimal point to show that is significant. Okay, let me show you an example here. A golfer collected 2,147 golf balls over a 10-year period from various courses for whatever reason. Report this considering significant figures. His collection of balls, although this really is a counting number, but this counting number has 4 sig figs. If we want to round that to 3 sig figs, then we will round the 7. We will round the 4 up to a 5 because it's adjacent to a 7. And so we get 2,150. If we want to round it to 2 sig figs, then we round the 1 to a 2 because adjacent to it is a 5. It gets rounded up to 2,200. If we want to round the 2,200 to 1 sig figs, then we would simply drop the 2 because it is less than 5, and we would get 2,000. But then we could make this 2,000 4 sig figs by simply putting in a decimal. If you put in a decimal, do not put a 0. If I add a 0, then it will become 5 significant figures. So the place value must stay the same when we deal with sig figs. We simply say strike as a way of saying ignore the zeros, either leading or lagging. The right-handed or the left-handed zeros are the only ones we need to ignore for sig fig counting. If we do math with the sig figs, we do the normal math and keep all the digits in your calculator first. Okay, then round to the lowest number of sig figs used in the calculation. Whatever the lowest number of sig figs used, that's going to determine what your final sig fig count should be. Do not count conversion factors or universal constants or standards when doing sig figs. In other words, do not count any of the significant figures that you look up on a conversion table or that are given to you in the problem. They are conversion factors and we can simply ignore them for sig fig counting. Example shown here, we have 1 times 21. The calculator would show 21. If 1 is not a counting number, and this should be rounded to 1 sig fig, then that's what we would do. Because the 1 here is not a counting exact number, then we would round to 1 sig fig. However, if 1 is a counting number, this number would remain 21. In the next one, we have 1.0 times 21. We punch our calculator and we get 21.0. Should be 2 sig figs because both of these have 2 sig figs. In the next one, we have 1.53 times 8.001. We get this number in our calculator. We go back and we note that 1.53, it determines the sig fig count because there are 3 here and 4 here. Therefore, I get rounded to 12.2 for 3 sig figs. In the next one, both these numbers have 4 sig figs. I record my calculator number and then I round the 4 sig figs. In the next example, 1,500 has 2 sig figs because this is a right-handed strike because there's no decimal. I go through my decision tree and determine there are 2 sig figs here. I go through my decision tree for the decimal and I determine there are 4 sig figs because this is a left-handed strike or ignore. I punch the calculator through and I get this value, and then I must round it to 1,500 because I only want 2 sig figs. As ridiculous as this might feel, this is the proper process for reporting to sig figs. In the case of the division, in the first number we have, this is a decimal number, therefore this is 3 sig figs because there's a left-handed strike and there are no left zeros. So this is 3 sig figs divided by 4 sig figs. I get this number, and then I round this number to 3 sig figs since there's 3 sig figs in my first number. What about addition and subtraction? For addition and subtraction, align the decimals. Count after the math. Do not count before the math is complete. In the case of multiplication and division, you can count before the math is complete. But for addition and subtraction, only count when you're finally done. Okay? Do the normal math and keep all digits. Round to the place value closest to the decimal point. If no decimal point is closest, then round to the non-decimal number. Let's take some examples. Here we have 4.0102 plus 2,700.23. We align the decimal points here. We add the numbers, and then we truncate to the shortest decimal place, which is 2 place values. So my final answer should only have 2 place values. This has 4 place values, this first number. Therefore, it's too long. This one has 2 place values. It's just right. So we truncate or cut off any of the digits after 2 place values. And we show you that here by aligning the decimals. And then we draw this line at the shortest place to the decimal or the nearest place to the decimal. And then we truncate, and then we report that we have 6 sig figs. Do not report or count sig figs in addition and subtraction until you have done the complete math and truncated. So here, we just show you some other examples of addition. We have these numbers. In the first example, so here we have 5,001 and 1.23754, and we add it, then we truncate because the closest to the decimal is a no decimal. And so this is 5,002 to 4 sig figs. In problem number 2, okay, we align the decimal points, we add the numbers, and we get this number. And then we draw the line at the nearest place to the decimal. In this case, it's 2 place. And then we count 1, 2, 3, 4, 5, 6 sig figs. Remember, round to the shortest, count after rounding. Round to the shortest, count after rounding. In problem number 3, we have these 2 numbers here. We align the decimal places, and here they are aligned right here. We add the number, and then we draw the line to closest to the decimal point, and this is our final answer. After I get the final answer, I will count 3 sig figs because this is a decimal, therefore a left-handed strike. Left-handed strike leaves me with 3 sig figs. Even though these zeros are still there, they're not counted in sig fig counting. We could do the same thing for scientific notation. We have these 2 numbers in scientific notation, 1.53 times 10 to the minus 5, and 1.022 times 10 to the minus 9. We align the decimal point, and then we add the numbers, or in this case, excuse me, we're subtracting the numbers. We subtract them, and then we draw a line to the one that's closest to the decimal, and we get 0.51 times 10 to the minus 9 for 2 sig figs. I can then write that in scientific notation by saying 5.1 times 10 to the minus 10. The first answer is correct, but it's not proper scientific notation. Therefore, after I do the math, I convert it to proper scientific notation, but note that the sig fig count does not change. Okay, there you have it. Short lecture on significant figures.